Okay, so if we're trying to solve this linear system, which of the two strategies would we use, substitution or elimination?
Substitution.
Substitution, how come?
Because you have two y's.
Okay, because I have at least one variable that's isolated. In this case, I actually have two, right? Even if I just had one, I still would use substitution, right? So what do? Well, if we've got substitution, then let's go ahead and just say, let's take, it doesn't matter which one, let's call this bottom one the substitution equation. And so every place on the top where I have a y, I'll plug in that stuff, right? So what's that give me? Then on the left side, instead of a y, we're going to have negative 5/8 x plus 3 equals, and then on the right side we've got, up here we've got negative 3/4 x plus 2, right? Make sense? Okay, so there's our equation. It's got only x's in it. Everything looks good except what's the issue here? This is the other thing. This is mainly the part I wanted to go through this. What do we got to do next? Austin, what do we have to do to get rid of those fractions? How would I clear the fractions? Because that's definitely what I want to do, right? Then it becomes easy. Okay, good. Find the common denominator, which is? No, okay, you're 8. Good. The smallest number that both of these divide into, which is 8, right? So then we'll just multiply each side through by 8, right? So if I distribute an 8 through both sides, what do we get? So it's like I'm multiplying by 8 over 1, right? So what's 8 over 1 times negative 5 over 8? Negative 5, right? Everybody agree? The 8's would cancel. Everybody see that? We always do it with my trick, right? If we're clearing fractions, we'd say, okay, 8 over 8 is 1, so we reduce first and then multiply by the top, right? Which is negative 5. 1 times negative 5 is just negative 5, so I get negative 5x. Well, here we just get 8 times 3. I don't have to do anything fancy. 8 times 3 is just 24, right? How about over here? 8 over, if I distribute to this guy, 8 over 4 is, well, no, okay, but 8 divided by 4 is what, Terry? 2. Good, so we know we're going to get a 2 multiplied by the top, and 2 times negative 3 is negative 6. Good, and then 8 times 2, 16. And so that's as far as we did from there. It's easy, right? Now we'll just, push all the, add 6x to both sides and isolate x, and it's no big deal. And once we get an x, once we get down to x equals some number, then I can just plug it back into either one of those first two equations. Say we plug it into the top one to find y, right? So what's this going to give us if we do this? Let's just finish this up real quick. If I add 6x to both sides, what do I get over here? What's negative 5x plus 6x? X. So x plus 24 equals 16. What's the last step? Subtract 24. And so what do I get then? What's 16 minus 24? Negative 8. So I get negative 8 for my answer. And if I plug that in back up here, I'll get y, right? I'm not going to get a fraction this time, but so what if I did? Big deal. It's the last step anyway, right? What difference does it make? If I got a fraction there, I would just add 2 to the fraction and I only have to deal with fractions one time then, right? My final answer might be a fraction, but so what? Right? Make sense? Okay, so clear the fractions is the moral of that story. All right, back to work.